Now let's take a look at focal chords and focal distances. Again, repetitive things. We have already studied about focal chords and focal distances. So let's say a standard ellipse has been provided to you. Of course, we take horizontal ellipse as our standard one. And here's our focus. If any chord that passes through the focus is known as our focal chord. And what is a focal distance? If in an ellipse a point P is considered at anywhere on the ellipse, its distance from the focus is known as focal distance. So PF1 is our focal distance. And let's say if we take it from the other focus, PF2, so that will also be our focal distance. And if you remember at the start of this chapter, we had studied that in an ellipse, the locus is defined as PF1 plus PF2. This is equal to a constant. And we had also studied that this constant is nothing but 2a. That means PF1 plus PF2 is equal to 2a, where a is the length of major axis, p is any point x comma y on the ellipse, and f1 f2 are their focuses. So this focal distance remains constant. So let us assume if ever in any questions you are given that there is a point and the focal points are given, focal focuses are given to you, then from that point to focal point you can add their distances and equate it to 2a so as to get the equation of an ellipse. Let's take an example. Here there are 2 points given respectively and p is any, so there is a ellipse given, 9x square plus 16y square is equals to 144. Let's take 144 here down in the coefficient of x square, so we would get x square by 16 plus y square by 9 is equals to 1. So this is our ellipse. Now they have given us 2 points, root 7 comma 0 and minus root 7 comma 0. So whenever you see that the question has given you 2 almost equal points, just there is a difference of a minus sign, that means these can be the focus of this ellipse. So let us check. So we know that the focus is written as AE comma 0 for any standard ellipse. So what is the value of A and E in this ellipse? So AE whole square, what is the formula? A square minus B square. So AE would be equal to root under A square, which is 16, minus B square, which is 9. So this would give us 7 root 7. That means this is our focus. So, and what is the question asking? And P is any point on the conic. That means this is our ellipse. This is our ellipse. The center is 0 comma 0. There is a focus f1 which is root 7 comma 0. There's another focus f2 which is minus root 7 comma 0. And there is any point P. So we have to find out PA and PB. So this f1 is nothing but A point, f2 is nothing but B point. So you have to find out PA plus PB. So PA plus PB can be written as PF1 plus PF2 as per this diagram. And we all know that if the focal distances are, the sum of focal distances are being calculated, then it is equal to a constant, and that constant is nothing but the length of our major axis. So what is this going to be? 2 into root 16, which is equal to 2 4 is 8. So 8 is our answer. Now let us study a little bit about equation of chord. So again, there is nothing different here. Exactly the same concepts that we had studied in circle, and then we studied the same concepts in parabola, and now we are studying here. So let us say if an ellipse has been given, there is a chord, the midpoint of the chord is given, x1 comma y1. This is our midpoint. If the midpoint is given, then what is the formula of the equation of this chord? We can write it as t is equals to s1. When midpoint is given. Now let us look at the equation of chord of contact. Let's say there is a point outside this ellipse, and from this point I draw two tangents here. So the point at which they intersect, if I join them, this is known as my chord of contact. And how do I write the equation of this? T is equals to 0. This is chord of contact. And if you all remember, let's say if x square by a square plus y square by b square is equals to 1, this is my ellipse. So T can be written as x1 by a square plus y1 by b square minus 1, and s1 can simply be written as by replacing x by the coordinates, plus y1 square by b square is equal minus 1. This is our s1. So this is how equation of chord is written. And let us say if another way of writing the equation of chord is, if you know that this is a chord, you know this point and you know this point, so by 2-point formula you can find out the equation of this chord. You can take out the slope and you can write down the equation by the formula y minus y1 is equals to m x minus x1. And you can also find out the point on the major axis at which it is intersecting, so that it becomes easier for you to calculate the equation, so that it becomes a 3-point formula. So this was all about the equation of chords. Now let's look at the position of a point. Let's say if in an ellipse there can be a point inside it, there can be a point on the ellipse, there can be a point outside the ellipse. So how do we find out? Again, we use the same concepts. For P1, which is inside, if S1 is less than 0, that means it lies inside. For P2, if S1 is equal to 0, that means it lies on the ellipse. And for P3, which is outside, S1 will be greater than 0. Exactly the same thing has been mentioned here. This is S1, S1, S1. So here if I bring 1 this side, this will be less than 0 again. They have removed the 1 and shifted the 1 to the other side. Again, it's the same thing as mentioned here. So if you remember just this thing, this will help you in all types of conics, be it circle, parabola, ellipse or hyperbola. Now again, let's do the same thing that we had done in parabolas. Let's look at the position of a line slash conic with respect to ellipse. Now let us assume a line has been given to you, y is equals to mx plus c. Again the same thing, and the equation of an ellipse is given, standard ellipse. So what we will do is, we will substitute the value of y in this equation. A quadratic will be formed, and upon solving that quadratic we would get the value of discriminant by doing, we will get the value of discriminant, which would be b square minus 4ac. And if d is greater than 0, we can say that the line cuts the ellipse on one or more points. It depends on the number of roots that we get for that equation. D, if it is equal to 0, it is a tangent, and if d is less than 0, it does not intersect. Now let's say if another conic was given, let's say y square is equals to 4ax. This was given. Again, this is an important thing that you need to remember. Y square is equals to 4ax is given, and x square by a square plus y square by b square is equals to 1. This has been given. So again, you replace y square by the value of y square, and again you will get a quadratic, and you can solve it and use the same output which has been given here. Now let us assume if somehow this conic was to transform into a biquadratic and not a quadratic, then you have to solve that equation in terms of the biquadratic. You assume that, let us assume ki x to the power 4 has become, let us say an equation has become in this format: x to the power 4 plus x cube plus x square plus dx plus e is equals to 0. Somewhat the equation is in this format. You have a biquadratic. So what do we do here? We assume that x square is equal to some other variable which is t, and then solve it in terms of our quadratic. Now let's look at, this is a new thing, reflection property. Of course, now this used to exist up until last year. However, this year it has been removed from the syllabus. But we will just look at an overview so that we know what concepts are used. There is one focus here, F1. There is another focus here, F2. Now a little bit of concepts that are used in physics would be used here. Let us say if any line is passing through this focus. Sorry. This is our ellipse. Let us say a line is passing through this focus. And we are saying that it can reflect from the inner side of an ellipse. Then that line after reflection would pass through the other focus. So this is our reflection property and nothing else. So why is that? So sometimes in question, up until last year, they used to give the equation of this line. The equation has been given and they said that it touches the ellipse at certain point and from there it gets reflected. Now it was your thinking that you had to use this concept that after reflection that line would pass through the other focus. So since this line's equation has been provided to you, so you can find out this point. This point is known to us, and once this point is known, you know that the other point is focus, that is also known to you. From there you can find out the equation. So this is how reflection property basically works from the inside. Now let's say from the outside. Here is our F2, here is our F1. Now let's say if a line was coming towards the focus, it was appearing to pass through this focus. However, after reflection, the line will pass in such a way that it is going outside this line. That means just a second. Let us say that any line is coming towards an ellipse. So after reflection, what will happen to this line is it will get reflected in such a way that it has been appearing to come through a focus. Sorry, this doesn't look very. It will reflect in such a way that it will appear that it was coming through this focus. So that is how reflection property basically works. So this was the end of the theory portion of ellipse. Again, there was nothing much or nothing new that we studied different from parabola. The only thing was that the shape and the geometry of ellipse is different, and there are two directrices, there are two focuses. We know how we can write the equation of chords, and each and everything is almost similar to parabola and circles as well. Now we will look into a few JEE mains previous year questions.